So that was all one-dimensional type information. Now we're going to go into a format that we're going to be more comfortable with, or I should say, we need to be more comfortable with, because that's the form the data values that we often analyze come in. So there's a so array is basically a multi-dimensional object. So it can collect or it can store specific values, specific modes of values in as many dimensions as you want. So if you want a three-dimensional object with all numerical values for all the dimensions, you would create an array. Matrix is a special type of an array because it's specifically a two-dimensional array. There are a couple of ways of using or creating matrices. One is by using the matrix command, and the other one is using the array command. For both of them, the first option is generally what values you want to put in. So this could be a data vector. Then you normally have to, for matrix, tell it number of rows and number of columns you want. And for the arrays, you can give it the dimension of your array. So that means for your first dimension, how many values, for the second dimension, how many values, and so forth. And there's actually another way of converting vectors into matrices, but I really don't recommend doing it that way. So here's an example. Here's a data vector. So you have 4, 12, 1, 15, 24, blah, blah, blah. So this is a vector of numerical values. And that's your first option into matrix. Then you can specify the number of rows you want and the number of columns you want. Okay, so you want 4 rows, 3 columns, and here are the values. And notice that it took these numbers and filled in column by column. Okay, there is an option in matrix that tells it to fill it row by row. Now, just as a reminder, the class of this object is essentially how it's being stored. So it's the matrix, and now similar to how you reference a one-dimensional, like a vector, by using square brackets, you have to reference a matrix using 2 values, basically giving it the row and the column values. One thing to note here is that mat here is the name of the matrix, right? So whatever variable this stores, and then you tell it what you want out of it. These are the other ways of creating the same matrix. You can use the array function with the same vector, and then the second argument is the dimension. Here you're saying you want 4 rows and 3 columns. Or if you just started off with a vector of numbers, you just force a dimension on it, and then all of a sudden it becomes a matrix. But I have never used this method. I've always used just the matrix command. Or, I guess we'll come back to that. So here, again, this is like a review, a way of referencing or getting or retrieving values from an object. You can use square brackets and you specify the values or the position of the values you want. In this case, it would give you back the first 10 values in X. Then you have a matrix mat, which will, again, you have to specify the rows and the columns. So here you're specifying the specific rows 1, 3, and 4, and all the columns. A logical vector, so you can, instead of using the position of the values or the rows and columns, you can tell it which ones to retrieve. So we did this example earlier of returning wherever it's true. So in this case, it will return the first and the second row, but not the third row, and give you all the columns, because if you don't specify, it gives you everything back. And same thing, we showed this for a vector earlier as well. But another thing that we can do actually is use names. So let's say we have a vector of these numerical values, and pretend like this is the price of the fruit or something, I don't know. So then we can put names on this vector. orange, banana, apple, and peach. So automatically, the position of these names are associated with the value, position of the value. So now you can say you want, from your vector fruit, you want the apple and the orange. Okay, so basically it will know that you want the apple and the orange. So it would return back to you values 1 and 5. Okay, similarly, on a matrix, you can add names as well. So you can be called row names or column names. One thing you have to note is the row names have to be unique. You can't have more than one row name that's identical. But column names, it's less stringent about. All right, so another way of creating matrices in R is when we use, by combining vectors. So other ways of combining vectors is C-bind or column bind and R-bind for row bind. So here's a bunch of vectors that I have. One is the blood pressure. So I have 132, 144, blah, blah, blah. You have the height of a patient and the weight of a patient. So let's pretend like these are measurements from each of the time the person visited. So here, I can create a matrix by doing a column bind of these three vectors. So this basically will combine all three of them into one matrix. So now, R knows that you basically put these three vectors together, so it keeps the names, it keeps the names together, but the rows it doesn't really know yet. So you can change the row names as you wish.